Here's a demonstration of how to trace through a copy protected disk using my Analyst Debugger. This disk happens to be the Merlin assembler, an early version from 1983. First we'll run Analyst. And then using the ampersand we exit to DOS and we'll start up the boot tracer. And switch back to Analyst. Oops, ampersand. Change disks. So now I'm reading the Merlin assembler disk. 9600 is the entry point to do stage 1 boot using the boot tracer. And this shows a standard DOS 3.3 boot. It's gone through boot 1 and boot 2 and now it's into the address B700. So that puts our WTS at B7B5 / tells Analyst to run that particular subroutine in immediate mode so it won't trace through it. There's a flag in Analyst to tell it to trace through ROM. Then we'll set a breakpoint at basic entry. It's the basic ROM entry E000, and we'll launch the trace through the boot tracer into the program. Now we've stopped at our breakpoint. Control C exits to the monitor prompt. Control L clears the screen. We can always clear the screen to get a fresh view. Being this is DOS boot, we look at the I/O vectors in 0 page, and we see 38 is pointing to 9E81, which is the keyboard input hook. So that is where when DOS loops through basic, which is where we're about to go into, it'll send a request into the keyboard input. So that is where we'll set our next breakpoint. And resume our trace. It has requested input. That's the basic prompt at the bottom. It echoes the prompt character, but then goes into the keyboard input loop, and that we've bounced back to Analyst now. So we do Control C to exit out of the trace again. Now we'll trace D7D2 is the basic run entry point, and what will happen is it'll load a basic program and then we'll trap it before it tries to load it, and we'll continue our trace. And here we are at the basic run point. Control C to exit. If we examine memory, we can see we do have a basic program in memory. This is an Applesoft program in memory, ready to be decompiled, whatever you call it. Anyway, ready to be run. And if we look at our page 3 vectors, this is listing at address 3D0 through address 3DC. At vector 3D3, we can see there's a jump to 9D84. That's a DOS reentry, which is used during the execution of this program. So we'll set our next breakpoint at 9D84, and we'll tell the program to run. Here's the opening screen. We're tracing through it. It's loading more of the program, and we hit the DOS reentry. At this point, it's going to 9D-E7 is the run entry point for a binary program. You'll see this in a second, because what it's going to do is actually run the first binary program called asm.obj, and we'll trap it at the point where it's going to run that program, and we'll continue our trace. Oops. There. Now we've hit the execution point, but this address is now in the 16K language card at E000. It's jumping to the language card to execute the next program. Now we'll run this program to a point that I've found while doing my examination of this thing. And here we are at a call to the RWTS. And if you watch the screen over here, you'll see what track and sector it's about to read. And I do a J, which will execute the subroutine shown immediate mode. And we see now we've read track 2, sector 10. That turns out to be a what you call a funny sector. It's got bits set in a certain way that it can't be read normally without this particular routine. And as you can tell, it has the carry set, which indicates an error has occurred. If the with the proper disk, this carry would be clear and the branch would go to D84C, but since we have a copy, it's not going to do that, and then it's just going to end up crashing. So what we'll do is we'll Control C out of this and set another breakpoint and execute where it would go. And this is one of the patches that's made to the disk eventually to defeat the copy protection. And here we are at D872. There's a TAX test which is done, and this is an important point because what has happened is the program has done a checksum of the critical routine the critical routine which reads the copy protected sector. This program has done what's called a checksum of that routine to make sure nobody has fiddled with it. And if you do alter that routine, which we will do, then this test will not pass. So this point has to be modified to make this program continue at D8AF. And since I haven't done any changes yet, because I bypassed the protection myself manually, then this test passes. So at this point it'll continue. Got to keep looking at my notes here. So we'll set a new breakpoint. And continue on our way. And this new breakpoint is going to be at where we encounter the next problem. Again, I think this is on these routines are in memory and not in ROM. They're on the language card. At this point, this subroutine is a call. Actually, what they did was they copied part of the F8 ROM into memory, so that's why I can do these calls. But what happened was at the time they used a copy of an older ROM, which when you try to execute this on an enhanced 2E ROM, they changed the firmware. So this routine will exit to a different point in the firmware, which on the enhanced 2E does not exist. So that's another point we'll have to change. Here they call the subroutine FE89, which sets the keyboard hooks, and it's the keyboard somehow. So I jump that, and with space bar or S key, you can step through a program. I step to the next instruction. Now here, this is an init call where we run into trouble. So if I execute this subroutine, it'll crash because it calls a unsupported point in the firmware. So what I'll do is I step into this with the S key. You have to step into a subroutine with the S key. And now we are at FB2F, ready to execute the next instruction down here. I'll Control C, and then through further tracing I found out where the subroutine calls the firmware of the Apple IIe Enhanced. So we'll set our next breakpoint. Continue our trace. And here it jumps out to the expanded ROM, I guess it's called. At C100, it's expanded ROM in the C100 space of the 2E. I'll Control C. The screen is kind of cluttered, so I'll do Control L to clear the screen. And continue our trace to another key point. In the expansion ROM. Here it's going to exit this ROM and jump back into the monitor ROM, F800 ROM, but at an entry point that's not supported. Well, what happened was he used an early copy of the F8 ROM, which is in memory, and that image in memory does not support this re-entry point at FEC5. So this is why the Merlin assembler crashes on an enhanced 2E. You get it just scrolls off the screen and it breaks into the monitor, which it actually hits a break instruction or break entry and breaks into the monitor. It throws the little asterisk prompt down, which captures back into DOS, which comes back into the program, and it just keeps looping. You get a whole lot of annoying beeps, and the thing scrolls off the screen forever and ever. So we need to do another patch. Eventually we patch the disk so it'll get through this point. And here we've got a mini assembler built into the Analyst. I included the mini assembler, which does assemble the 65C instructions as well. And we'll pick the address that needs to be changed, and we'll put in the code that should be there. Oops. And one problem is, I forgot this, that is in the language card ROM, and right now it is write protected. So we have to enable C083 twice. Read and write enables the card so we can make our changes. We'll go back in. Oops, 5. And we'll put in our code. Mini assembler, you always just type space to enter the next instruction. And on my mini assembler, if you just press enter, it exits back to the prompt. And now we can continue our trace, and we should be running the assembler. And there we are. We're full in to the Merlin assembler, doing a trace, and we can do some functions like catalog and so forth, and we're in a functioning program now. So then these couple of patches have to manually be put on the disk I use Copy2Plus sector editor, and I've included that in the file with the disk images that I uploaded to the our Facebook group's website. And that's it. This was a lot of fun.